review what's Kubernetes, Spark and Kubernetes architectures and pros vs cons, a live workshop, and a summary at the end. Feel free to ask me any kind of question during the sessions, and I'll try to answer all of your questions. Okay, great. So what is Spark? Spark is basically an engine that can process really large scale of data. It's one engine that can process many kind of applications. Its in-memory advantage in the cluster brings much more faster processing of applications. It could be 100K improvements of application running. It can support different workloads. It could be batch workload, iterative, streaming, SQL, and etc. And it can support also multiple languages in different environments. So it's very, very easy to use on different kind of workloads and languages like Python, Scala, R, and so on. So basically, we can deploy Spark in a few modes. We have the Hadoop Yarn. That's a classic deployment mode that a lot of enterprises use. Some of them also use Apache methods. You can use Kubernetes, and you can also use a standalone mode. It really doesn't matter which kind of deployment mode you try or you want to use. Once you have one of them installed, the Spark core engine is one for all of them. It's the same one. So you can switch between Yarn and Kubernetes, but your code in the Spark context and every application that you run on top of Spark will be the same. So that's really cool and advanced in Spark. In the last webinar, I spoke about what's Kubernetes, so I'll do a quick review of what is Kubernetes and why we need Kubernetes to run Spark. So basically, Kubernetes provides us an abstraction layer to run containers. Everything in Kubernetes is containerized, so it provides runtime environment for all Docker containers that you can run on top of it. Everything in Kubernetes is natively load balanced. So that's really important in Spark when you have a huge load of data processing that you want to run, and you need a huge amount of nodes to execute the job. So Kubernetes will load balance automatically your nodes in Spark cluster, so it can run the jobs very quickly. It will monitor the health of the container. So let's say you run on Spark instances like in AWS or Google. Once the Spark instance will die, Kubernetes can create a new instance and bring it to the cluster automatically, so you don't need to take care of those. It has advanced scheduler, so you can run your Spark jobs on Kubernetes schedule and enjoy the advantages of it. And most importantly, you can use Spark and Kubernetes on any kind of cloud provider and bare metal. It doesn't matter. You have one API and one unified application for Spark and Kubernetes. So this is really cool and can reduce the time that you spend on creating Spark clusters. So Spark architecture on Kubernetes is very, very simple. You have the client here that will run the Spark submit jobs to the Kubernetes. It will speak with the Kubernetes with the API server that can speak inside of the pods and nodes inside the Kubernetes, and the scheduler to schedule the jobs. So once you use Spark submit using a kube control, the Spark will create a Spark driver as a pod, as opposed to Yarn or standalone cluster or methods that it will create a master and then only the driver on the master node. Here you will get the Spark driver as a pod on the node, and then the driver will create the executors, basically pods, to run the application code. So the pods could be on one node, and it could leverage many nodes in the cluster. So that's really important. And the third thing is when the job is finished, all the nodes will be terminated. So you don't need to keep a huge cluster online. You can have like only the master, the node of the master, and then once you submit the job, it will scale automatically to bring all the other nodes to run the application. I see that we have one question. So yeah, one pod can run one executor. Yeah, you can change settings. of the code of the execution, but one pod will run one executors by default. Okay, great. So what's the pros and cons of Kubernetes on Spark? So Kubernetes can manage all your containerized pipelines. So think of that maybe you already have containers that run some of your application pipelines or do some pre-processing on your data. You can just put it in Kubernetes and Kubernetes will just manage it and run it automatically. You don't need to change your ways. So that's really awesome and could help you do better engineering on the Kubernetes and Spark. Like I said earlier, you get optimization for resources. So everything is load balanced, everything can scale up and down automatically. So you don't need to keep really huge clusters anymore alive. You can just keep the master, and the master will leverage Kubernetes capabilities to bring up more nodes if it needs to add more nodes to the cluster. The Spark can also leverage one of the Kubernetes resources advantages is persistent volumes, service mesh like Istio, and advanced scheduling system. I think the most important thing to note here that Kubernetes on Spark on Kubernetes is in beta stage and could have some issues when you run huge jobs on your cluster. So take that as note when you have your Kubernetes implementation. So now I will share what we're going to run. So we will use GKE for Kubernetes cluster with the auto-scaling feature enabled, just for bringing up a cluster really quick and easy. GKE is one of the ways to do it. We will create a Spark Docker, official Spark Docker, to use in our Kubernetes cluster. We will push it to Docker Hub, and then we will use it in the cluster. And then we will just calculate the pi value on the cluster. Great. So let's do that. I'll share my screen again. Okay, great. So here we have our Google Cloud Platform, my Kubernetes cluster. This is the GKE. GKE is the Google Kubernetes engine that Google provides us to build a cluster that they manage, and really quick and easy to do it. You just go to your Google Cloud Platform, you go to Kubernetes engine, clusters, you will see this page. You can create a cluster. So you give it a name, my test cluster. You can leave the default zone, US Central, and so on. That's not really important now. You can change how many cores you want for each node. So you can have, in the beginning, only one for your master. You can have 2 CPUs and 7 gigabytes of memory. And I will want to say that I want to enable auto-scaling. That means that I want to start from 1, and I can scale up to 10. So if I have a really huge and heavy workload, Kubernetes will leverage the auto-scaling feature and will create more nodes in the cluster. And we'll save it. And now I will just create it. It could take a bit, about 10 to 12 minutes to create a cluster. So we'll just use the cluster that I created earlier. Okay. The way to connect to the cluster, it's really easy. You go here, you press connect, and then you can either run it in a cloud shell, or you can copy that to have the kubeconfig to talk with the cluster. So now it will download my kubeconfig, and now when I run kubectl get nodes, I will see my cluster information. Okay, so I have 3 nodes. One of them are 6 hours up, and 2 of them are 4 hours up. Okay, great. So now we have a cluster. What we will need to do is to build the Docker image. This is also very simple. Spark basically built it for us. We just need to run the commands. So you go to the Spark official website. You can choose either one of the versions and the pre-built Hadoop. I just use the 2.4 and the 2.7 Hadoop. And then you just need to download the tar that they bring you. Just need to download it. Once you have it downloaded, you will find all the resources that Spark needs. So if you see you have your Kubernetes folder, you go inside the Kubernetes folder, you have Docker file, Spark, and here you have the Docker file that Spark provides. I'll open it so you can see it. Okay, so it takes from JDK, Spark runs on Java, it has to have Java, so you need that in your cluster. It will set up some configuration files. You can see that Spark is installed in /opt. So you can see here the Docker file. And now I would want to run the Docker file to build it. So basically, I will go to the Spark 2.4. Okay, now I will run a command that builds the Docker image. Okay, here I can set up the Docker image that I want. It could be any kind of Docker image name. Demo Spark, let's say, and the version of the Docker. So it could be the version of the Spark, or it could be also V1 and so on. Now it will build my Docker. I already built my Docker earlier, so we won't need to wait. So if I'll stop it and I'll do Docker images, you will see that I have my convert Spark example Docker that I built 6 hours ago. So we will use this Docker. I already pushed it to Docker Hub, so anyone can download it from Docker Hub to the container. It's free and public Docker, so you can use or you can build your own. Once we did that, we would want to configure the Kubernetes to run Spark jobs. So we'll basically need a few YAML files. If you don't know, Kubernetes speak with kube control and YAML files. I see that we have a question, just a sec. Yeah, so someone asked if I can elaborate on Spark submit vs Google Spark operator, and I will elaborate on this in a few minutes after I'll show how to run the Spark submit. Okay, so now I have a few YAMLs that I want to run in your cluster. Okay, so first of all, we will start with the role YAML. Basically, this role means that we allow the Kubernetes cluster to do the autoscale and to add new nodes to the cluster and also delete them once the Spark submit is over. So this is really important because we don't want to leave your resources up just because you forgot to delete them. So once you bring the cluster the ability to delete the node, it will autoscale and then it will make the cluster bigger and then it will make it small. Choose the role, we will bind it with a service account. Service account in Google is basically like the IAM role in AWS. It's like the credentials for the cluster to run anything that it needs on top of the GKE cluster. And here we will just bind the role to the service account. So once it's in the Kubernetes cluster, you can use it to run the workload. The second YAML is the service. The service is the way the pods talks to each other, so they need to understand in which ports they talk, who is the driver, what you're gonna run, Spark job, and so on. The third one is config. So the Spark needs a few configurations to be able to run the cluster and the jobs. So this will be mapped on top of the Spark driver. Okay, you see the Spark master Kubernetes IP. This is the master IP of my cluster. And the way to get it is to go back to the kube control and do cluster info. And now you will see that we have Kubernetes master running, and you can just copy that. You can also put the whole URL, that's also fine. Kubernetes knows how to handle that as well. so don't worry about that. Here we will say that we want the Spark UI to open on port 4040 to bind the address of the local host of the network, some Python drivers, and so on. And here I will say how much cores and memories I would want for each executor. Okay, great. Awesome. So last thing is our job that we're going to run on top of a cluster. So we're going to calculate the pi value on the Spark cluster. So we will use the Spark submit application. We will run the pi value of the Spark official examples. We would want to run it in 1 million iterations. I'm going to add the tel -f dev now just for the cluster not to run the same pi job over and over. This will make it stop after the first iteration. Okay, here I will say the Docker image that we're going to use. So Kubernetes will try to find the Docker on the node, the local node. If it won't find it, it will just pull it. Since it's a public Docker, it doesn't need the credentials. But if I had a private Spark image, let's say I modified it, you would need to use your own credentials, and you can provide it here. Here you will say the resources for the drivers. I will give it 1.5 CPUs. Please note that you don't have to use a full integer. You can split it to fractions as well. And here I will say that I want you to take the config map and put it here in the /opt/spark/conf. Like we saw that Spark is deployed on /opt/spark, so it will look for the configurations that we gave in the config map. Here, it will map it to this location. Great. So now we can run it. Okay, great. Okay, so now I need to run all the YAMLs that I just showed. So I'll do ls, and then I'll do kubectl. Yeah, okay, good. Kubectl apply -f. We will start with the role. The role YAML. Oh, sorry. Okay, so now it will, since I ran it earlier, it hasn't changed, but if I change it, it will reapply. I will do the same for the service YAML. I will do for the config YAML. And now I'm ready to run my Spark job. Okay, great. So now it's configured. I can do kubectl get pods. I will see that I have my master running. Okay, I can do logs to my master. Okay, and now here in the log of the master, you will see all the logs and maybe errors if you have. So this is an error from an earlier run. Okay, great. I can also delete the earlier job if I want to start over. And now when I'll do, I will see that it's terminating, and I can just reapply it. Okay, now we see a new one running, and we'll go to the logs again. And now we see all the logs. We can do even watch, and it will get updated as we go. And we need to check that it really creates the executors, like we said earlier. So we will run again kubectl get post, and we'll see that it's creating those executors, 4 of them. We will go to one of the logs of the executor so you can see what's going on here. So you see it's created, it was attached to the master node, and now it will run the job, the portion of the job that it was meant to run. Here's all the arcs. See that it's running, and it will be finished soon. So we saw that we can run our PyPy Spark job on top of my Kubernetes clusters. Once it's done, everything will be terminated here, and Kubernetes will terminate the nodes that it was just allocated for the workload. But we see that it's very hard to follow the log and see what's going on inside of the Spark cluster. We can leverage the Spark UI, but again, it will be harder for us to see the results of the jobs. So I'll just show you a quick demo on how to do it in Converge and how Converge leverages the ability to run Kubernetes and Spark in one unified platform. If I go back to the presentation, we can speak about why it's good to run your Spark workloads on Converge. So Converge leverages Spark and Kubernetes application to one unified system, so you can run any kind of job on Spark or on Kubernetes from the platform. You can reproduce and follow your job. So if you have a really huge pre-processing data workload, you can follow your jobs in Converge, see the logs, see the results, monitor your jobs, see that the health of the Spark workload is good, that it doesn't use too much memory, and so on. It's really simple and fast to do it. I will show it in a few seconds, and you really get the clarity of what's going on in your Spark workload. So let's go back to the home. So this is the Converge application. I can either open a Jupyter notebook on top of my Spark clusters, or I can just run a Spark submit job on my Spark clusters. It doesn't matter. Once you have Kubernetes, you can run any kind of workload, either machine learning, classic machine learning workload, GPU training, or a Spark cluster. It's really easy to start a Spark notebook. You just choose Jupyter notebooks, and then in the compute, you will choose the Spark, one of the Spark templates that you have. So you can use Spark Small or Spark Medium, or you can create your own template. You will start a workspace by going here, and now we will allocate all the resources for your Jupyter notebook on top of the Kubernetes. I will go to my workspace 3 that I already have my Kubernetes, my Spark and Kubernetes ready to run. Once you run everything on Converge, you will have a Spark UI manager that you can see what's going on on top of your cluster and see that the jobs are progressing correctly and so on. So we will open the Jupyter notebook on top of the Spark cluster. We can now run the Py job using the PyPy example of Spark, sorry. Okay, so I will run this again. Once I run it, I'm able to go to the Spark UI Manager and see what's going on. It will be up in a few minutes, and see that my job are progressing as well. If I don't want to use Jupyter Notebooks, I can just go to the Experiments tab. Okay, so now we can see our executors, we can see our jobs. We have now a job that's duration of 8 minutes. It's running 62 out of 10K partitions, so it will be ready soon. Okay, we can see what's going on inside of each executors as well, and follow our jobs. And I can also go to my experiments. I can go to new experiments. I can run Spark submit PyPy with the 10K iterations. I will choose again the Spark compute, and at the end I will submit it. Once submitted, the same thing goes to Jupyter Notebooks. It will go to the Kubernetes. We'll allocate the resources for the Spark, and we'll run the Spark submit PyPy value. You can see here that we get the dashboard for my experiments, and I can follow all the logs of the of the job. So that was really hard doing that with the kube control config and pod logs. But here everything is already in one place, and you can follow, you can see what's going on, and you can see that the pi value that we got was a bit close to the real pi value. You can see the partitions, you can see what's going on in terms of memory, CPU, and network, and you can follow your jobs. Great. This is all the logs, all the Spark master logs, and you can see the result at the end of the job. Awesome. So let's go back to the presentation. Summary of what we just saw. Spark is a unified analytics engine to run really huge, large scale of data processing. It leverages the in-memory ability to run really huge data processing. Kubernetes is a platform for abstraction of containers orchestration, so you can run any kind of container workload on top of your Kubernetes cluster. We walked over and saw what the different implementations of Spark. We saw how Spark is implemented in Kubernetes architectures, the pros and cons of running Spark on Kubernetes. Basically, that Kubernetes is in beta stage, but you can still run your workload and get really impressive results in faster time. We ran a full Spark on Kubernetes workload from creating the Kubernetes cluster using GKE through building Docker image and publishing it to Docker Hub, and then running the workload on the Kubernetes. And also we saw how to do it with Converge, that it was really easy, and you can manage, monitor, and automate your workload using the platform. So we have another question. How is the performance of Spark on Kubernetes is compared to any non-containerized environment? So some users, some heavily Kubernetes users say that they saw the improved of speed of the performance of the jobs, mainly because of the ability to auto-scale your workload. So if you don't know how many nodes you need, Kubernetes, you can do the calculation for you and will bring the best results for it. So this is really cool. That's basically what we also saw that is improved in the containerizing of Kubernetes. You can also think about that when you have containers that run your jobs, you can run it anywhere. And you can deploy to production as well and do a lot of stuff with containerized as opposed to Yarn architecture. Great. So if you don't have any other questions, we will